Welcome. In today's video, we'll look into object detection using AWS Rekognition, which is Amazon's powerful computer vision service that can identify thousands of objects and activities in both images and videos. Imagine building an app that can automatically detect people, track vehicles, or even recognize objects like backpacks, phones, or helmets in a live video feed without writing a single machine learning model. That's the power of recognition. So whether you are working on a smart city surveillance, content moderation, recognition gives you a scalable production-ready toolset backed by AWS infrastructure. In this video, we'll walk through a real-world demo app showing object detection in both images and videos, following which we'll also have a quick overview of pricing so you know what to expect if you want to build your own solution. So let's get started. But before we move ahead, let's look into what exactly is AWS Rekognition. Amazon Rekognition is a powerful image and video analysis service offered by AWS that uses deep learning to identify objects, people, text in visual media, all without requiring you to build or train your own machine learning models. It's designed to make computer vision accessible to everyone from startups to enterprises with just a few lines of code or simple API calls. So what can you actually do with recognition? You can detect common objects in photos like cars, laptops, animals, or even scenes like beach or city. You can extract text from images like license plates, documents, or storefront signs. Using recognition, you can also flag inappropriate or unsafe content for content moderation. And it even works on videos, tracking object movement, detecting labels frame by frame, or monitoring live camera streams. Recognition is fully managed and scales automatically with your usage. You don't need to worry about deploying infrastructure or managing services. Just send your images or videos to the API and you get structured, actionable data back. It's being used today in industries like e-commerce, media, logistics, and security, and it's a great choice for adding visual intelligence to your applications quickly and cost effectively. In this video, we are focusing on object detection in images and video, which is one of the most practical and widely used features of recognition. In the subsequent videos, we'll touch upon other features of AWS Rekognition. So, let's start with the demo. Alright, now it's time to see AWS Rekognition in action, and we have built a simple demo app specifically for this video that taps into Rekognition's object detection API and shows results for both images and videos. So let's start. We'll first run the app. Now I'll just open it in the browser. So this is the interface of the app. It's pretty simple and very to the point. The instructions to use the app has also been presented on the screen. So all you need to do is upload an image, and if you want, you can set optional advanced options as well. And then you just need to click on the detect object buttons, and that's all that you need to do in here for this demo. So we'll start with the image. I have uploaded one image. We will currently not go with the advanced options. We'll just directly click the button and the analysis has now begun. So as soon as we uploaded the image and clicked on the detect objects button, the image was sent to AWS Rekognition using the detect labels API, and what we get back is the data after analysis and the processed image that we are displaying here using that data. Alright, so this was our original image. Let me just open the image in here so that we can have a proper look. So this image is a street view where people are crossing the road. There are vehicles as well, traffic lights, there are flags. So this is the whole scenario in here of a city. Alright, now the processed image here we can see. So this is the processed image, and we have drawn bounding boxes around the objects that have been identified using the data that we received from Rekognition API. All right, so let's just zoom in so that we can clearly see how precise and accurate the detection here is. You can see that with a lot of accuracy, with a lot of confidence, it has detected cars. Like here, this car particularly has been detected with 97.8% accuracy. Then another car here is detected with 97.4% confidence. Then we have this bus also, which have been detected with 82.8% accuracy, or we can say the confidence. Then if we zoom in a little bit further in here, then we see that handbags of people have been identified here as well. Here also hats have also been identified, their shoes, people, all of it with great precision have been identified in here. The traffic lights, even the road sign as well have been detected, the flags too. You can see here, this is the output. Basically the output is not this image. The bounding boxes have been drawn by us in here, just so that we can put across like it has detected everything. All right, so now if we come back to the detection results, so we have seen the original image and the processed image, and we can also download the processed image as well. The option to do that is here. All right, then there is this data section where the data that we received from the API has been tabulated so that we can understand it better. So let's take a quick look at the results table in here. So the first column represents the label that have been identified, that we are even writing along with the bounding boxes in the image. So this is the name of the object or scene that Rekognition has identified. All right, so here we can see that a city has been identified in here. Now this is not an object, but that scenario was of a city, so the label has been added in here. Then we saw traffic lights, persons, accessories, bag, handbags, footwear. So all of it have been listed in this particular column. Then the next column is pretty to the point. It is the confidence level with which the labels have been identified. Then we come to the next one, which is the instances. Now this column shows how many separate instances of that object were found. And for some label, this may be 0 because they represent a broader scene or concept rather than specific countable objects. So for example, in this image, anybody can see that this is an image from a setting of a city. All right, now city can't be counted, so the number of instances for city here is 0. Same with urban and metropolis and a neighborhood. All right, so instances for these are 0, but as you can see, for traffic lights the instances are 12. And if I click on the details button in here, then for all those 12 traffic lights that have been identified in the image, the confidence level with which they have been identified and the dimensions of the bounding box has also been provided. All right, now let's move on to the next column, which is object counts. And this shows the total number of object recognition identified for that particular label. All right, so even if they are not all explicitly counted as separate instances. So here now a city have been recognized once, so object count for it is 1. All right, although number of instances for it is 0. So I hope this makes sense. So for example, light is a broader term. It has been identified in here once for this particular image, so object count for it is 1. But traffic lights have been identified as 12. All right, I mean the instances for it was 12, so the object count for it is also 12. All right, so there's not going to be a 0 object count for anything that has been detected. So if something has been detected and is a part of the label, then the object count for it is going to be 1. Now we come to the next column, which is the aliases. So these are alternative names or variations of the detected label. So for example, Here city, the label city can also be called a town. So the alias for it is a town. Alright, same with tarmac. So currently in the image we can see that these are tarmac roads, but we can also call it an asphalt road. So the alias for tarmac is asphalt. Alright, and so on. For person it can be human, for accessories, accessory. Alright, so this is what the aliases mean in the result. Then we have the parents column. These indicate broader categories or related labels. So for example, here the street is detected. So for example, street is detected here, so it might be listed as a part of a city as a parent label, showing its contextual relationship. All right, so for example, this street is going to be a part of a city. Metropolis again is a city. So this is a broader group under which the labels are going to be there. All right, so for example, traffic light is a part of light. Okay, like there can be different kinds of light. There could be bulbs, there could be tube lights, then there could be traffic lights. So under light, traffic light is a subset of light. All right, so this is what it means. So these parents are encompassing these labels, and you can see that a parent can have many labels attached to it. For example, street is a subset of city, and metropolis is also a subset of city. All right, but at the same time we can see that street is also a subset of road or urban as well, but metropolis is not a subset of road. So there is many to one relationship between parents and the labels. All right, then we come to the categories. So this column shows the high level group or domain the label falls under, such as buildings and architecture or transport and logistics. So here we can see that city falls under buildings and architectures. Then road falls under transport and logistics. Then a person also falls in person description. So all in all, we can say that categories is even broader group which encompasses the parents, and then parents encompasses the label. All right, so like this is a hierarchy from categories to parents to labels. So this is the kind of result that we get from recognition, and it is very detailed. Also, along with this kind of information, we also get the information about the bounding boxes for each of the objects that we have identified in here. For example, for shoes also we can see that the dimensions for the bounding boxes are also presented to us. Then moving forward, let's take it up a notch and try out the advanced option as well. Now here the advanced option basically allows us to flag a certain object. So for example, let's say if we are automating the analysis of an image and we want to be notified if some particular object appears in the image. For example, it could be a knife or any such thing, a car, a person, or a dog. So if we are monitoring that, so this option is for that purpose. Now again, I'll be selecting the same image so that we can compare again with the same result in the detection results section. And I'll go with car. I'll just say that please flag a car, and we'll be detecting the object now. And here again we have the same kind of results. I'll just open it here. So initially this was our response. All right, this was the first response when we ran the app without flagging the car, and this is the response that we get now. And here you can see that now the bounding boxes are red in color because this particular object has been flagged. All right, in this image please ignore the other bounding boxes. We are specifically talking about car. We can also make it so that the bounding boxes would be only drawn around the flagged objects. So here the car has been flagged, and you can see that the text for it is displayed a little differently to differentiate that this is a flagged object. And coming back to the interface, we have one more tab which is for flagged objects, because now a flagged object has been detected, and it even gives the warning here that okay, this particular object have been detected and that there are 10 instances of it in the video. Alright, so this is how it works. Now let's just try it out with a video. So I'll be uploading a video now. I'm not going to again use the advanced options. We'll just go with the detection now. Also, it takes a bit longer to process a video as compared to an image. So for videos, recognition works a bit differently. We start by uploading the video to an S3 bucket, and then we use the start label detection API to kick off an asynchronous job. So once the analysis is done, we fetch the results using get label detection. So here is the result. We have the original video and then we have the processed video as well. Let's just now look at the video. So this is the original video. No detection is being performed in it here. This is the video that we uploaded. And now let's look at the processed video. So here you can see that the objects are being detected in here as well. Since the pace of the video is a little bit faster, we are not able to see it. But let me just pause it somewhere and then, yeah. So here we can see that a person has been detected wearing a handbag, then another person, their shoe, a person here as well, which is mostly covered by this car, as you can see, but still it has been detected with a 92.5% confidence. The wheel of the car has also been detected. Then here we see the fire hydrant has also been detected. So you can see how detailed and accurate the detection is. Alright, so let's come back to the interface, and here also we have the same kind of data in the same format. Alright, so we don't really need to explain it, and we also have the option to download this as well. So let me just open this. Okay, so this is the CSV file, and here as we can see here, there are 19 people that have been identified in that video segment, and their bounding box dimensions and confidence levels have also been given, and the same has been listed here also. So we are not missing any information when we are saving it in a CSV file. Alright, so you can see how incredibly powerful Amazon Rekognition is for the purpose of object detection, and with just a few lines of code and some AWS setup, we were able to add real-time object detection to our app, and you can do that too with your own apps as well. And with this, we'll wrap up the demo and move on to the next section. So let's talk about something every developer, startup or enterprise needs to know, that is pricing. And the good news is you only pay for what you use. There's no upfront commitment and no minimum fee. Pricing is broken down into two main categories: image analysis and video analysis. So let's explore each. In case of image analysis using static images, AWS charges you per image processed using the detect labels API, and the pricing is tiered based on how many images you analyze in a month. So for the first 1 million images, you are charged $0.001 per image, and for the next subsequent 4 million images, you are charged $0.008 per image, and so on, as you can see in the table on the screen. So the pricing are dependent on the number of API calls you are making and how many of them you are making. To understand it better, let's take a look at an example. So if your app processes 2.5 million images per month, the total cost incurred would be $2,200 per month, as you can see based on the calculations which is shown on the screen. On top of this, if you also want to analyze the image for its quality or dominant colors, then you'll need to use image properties, which is an optional feature of the detect labels API, and you'll need to bear additional costs for that. So for the first 1 million images, you will need to bear an additional charge of $0.00075, and for the subsequent 4 million images, you will need to bear an additional charge of $0.0006 per image. So here you have the option to either only use label detection properties or only use image properties using the Detect Labels API, and the pricing for both have been shown on the screen. So in case if you only choose to extract image properties from the Detect Labels API, then you'll only need to bear $0.0075 per image for the first 1 million image. Now let us move to label detection in videos. And for video files stored in S3 bucket, AWS Rekognition charges per minute for label detection. So here's the catch. For images, it is per image, but when your input is a video, which is a static video stored somewhere, then the pricing is based on per minute of the video. So let's take a look at an example to understand how the costs would be calculated. So if your app processes 100 minutes of a video, then the charge for processing the video would be $10. Also, if you want to work with live video streams, the cost drops to $0.00817 per minute, but you will need to use other AWS services along with that as well, and the cost for them would also be added to the billing separately. So if you are interested, then let us know. We'll discuss that in another video. Moreover, there is also an AWS free tier which is available when you first get started with AWS for the first 12 months since you join AWS. And in AWS free tier, you get 1000 images per month for label detection as free. Alright, so for the first 1000 images per month for the first 12 months, you won't be charged for using this service. But it should be noted that image properties and video analysis are not included in the free tier. So this was the pricing breakdown for using AWS Rekognition. Now let us move to the next section, which is when and where to use Rekognition. So you can consider using Amazon Rekognition when you need fast and scalable object detection without building your own ML models, or when you're working with millions of images or videos and need an API that just works for you. You can also think of using Amazon Rekognition when you want to analyze content in real time or batch process at scale. Moreover, you can also choose to use Amazon Rekognition when you prefer serverless pay-as-you-go pricing over managing infrastructure. If these points relates with you, then Amazon Rekognition is the right tool for your object detection needs. Now that we know when we should use Amazon Rekognition, let's break down where Amazon Rekognition is actually making a difference across industries, and not just in theory but in real high impact scenarios. So the first scenario is retail and e-commerce. In this scenario, Amazon Rekognition can be used for automated product tagging, where we can use it to scan product images and instantly generate relevant tags like red shirt, leather bag, or sports shoes, etc., helping retailers improve search and recommendation systems. Or it can also be used for in-store analytics, where we can use it in camera feeds where it can detect shopping patterns, identify where customers are spending time, and even detect stockouts or misplaced items on shelves. It can also find its use in media and entertainment scenario, where it can be used for content indexing, where news agencies and media houses use Rekognition to auto-tag massive video archives, identifying objects, scenes, and activities for faster content retrieval. It can also be used in sports analytics, where it can detect objects like balls, bats, or goalposts to automatically clip and tag key moments in games. Another use case can be found in healthcare and medical imaging for non-diagnostic things. So while it currently can't be used for diagnosis, object detection can help in inventory management, where it could be used for tracking medical tools or PPE, monitoring patient room setups, or verifying the presence of medical devices in certain environments. It has also found its use in agriculture, where it can be used for drone footage analysis. Farmers use drones to capture images of fields, and recognition helps in identifying farming equipments, livestock, or even signs of crop damage, saving time and resources. It can also be used for livestock monitoring, where it can detect presence and behavior of animals in large areas via aerial surveillance. Additionally, one of its most prominent use cases can be found in security and surveillance, where it can be used for threat detection. Here, recognition can detect restricted objects such as weapons or hazardous materials in real-time feeds. It can also be used for restricted zone monitoring or crowd monitoring, where it can be used to identify overcrowded areas and can detect dangerous equipments or items. And the last use case that we are going to discuss in this video is logistics and warehousing. It can be used there for package tracking, where object detection can help ensure packages are correctly sorted and tracked as they move through conveyor belts and loading docks. It can also be used for damage detection, where it can identify visibly damaged goods or packaging before they are shipped out. So, these aren't futuristic ideas, these are real applications already being deployed at a large scale. And the best part is you can build these solutions without being a machine learning expert thanks to Rekognition's pre-trained models. So, if you are looking to integrate object detection into your application or explore how Amazon Rekognition can solve your specific business challenges, Codersarts is here to help. We specialize in building custom, scalable, and production-ready solutions using AWS services like Rekognition, tailored exactly to your use case. Whether it's analyzing images, processing videos, or automating tasks with AI. So whether you are just getting started and need help with implementation or want a full end-to-end solution, you can see our contact details on the screens, and you can also find our social media handles in the description box below. Also, if you found this video helpful, don't forget to like, subscribe, and turn on notifications so you don't miss our upcoming videos, including one focused on face recognition and video analytics using Rekognition.